Welcome to Naval Dockyard Limited. Before now, has any of you been here in Naval Dockyard before? No? Do you have idea of what we do here in Naval Dockyard Limited? Indicates. Let's have it. What we do here in Naval Dockyard? Naval Dockyard Limited is a naval engineering institution. Here we design and build ships, most especially naval ships. Before now, Naval Dockyard Limited is being managed by a civil institution. Naval Dockyard Limited presently, we build about 3 ships: NNS Caradua, NNS Orgy, and NNS Andul. This building that you are standing is a ship design building. We move in and we have instructors that will tell you more about about ship design and building. We have naval officers that are trained in this aspect. So without much ado, we start moving in. Let's move in.
First of all, my name is Engineer Johnny. What is my name? Okay, I welcome you to Ship Design Center, the subset of Naval Dockyard Limited. Okay, Ship Design Center is a place or is a department where ship design analysis is being carried out. What is Ship Design Center? Ship Design Center is a place or a department where ship design analysis is being carried out. What is Ship Design Center? Who can tell me? Okay, can you raise up your hand if you want to answer? Ship Design Center. Who can tell me about Ship Design Center? Okay? Who can try? Okay, Ship Design Center is a department in Naval Dockyard Limited where ship design analysis is being carried out. We use various softwares which is where the design is being carried out. Like we are using AutoCAD to come up with 2D design. We use SolidWorks to come up with 3D design, that is like model of the ship. And also we use various softwares like AutoShip, AutoHydro, and so on and so forth. Do you know what is software? Do you know what is software? Who can tell me what is software? Okay, who can tell me what is software? Okay. Software, we use it to design. We use it to come up with design. Like, okay, if now someone wants to give me a project, like you want to build a ship. Do you know what is ship? Okay, what is ship? What is ship? Okay, listen. Ship is a movable. Okay, someone want to try. Okay. A ship? Sorry?
The ship is a vessel that moves on water.
Okay. Do you hear him?
Yeah.
What did he say?
Ship is a vessel that moves on water.
a ship is an object that floats on a water. You understand? It's an object that floats on a water. Okay. On that flotation, there is various engineering knowledge which makes the ship to float, which we call Archimedes principle. You understand? So that principle, and also the various engineering principles like Bernoulli's equations and so on and so forth. You understand? Is what makes the ship to be stable on water so that it can float, it can go front, it can go back. You understand? So ship design is a place where all this is being considered to come up with a project as a ship. You understand? And this is military environment where ship is being kind of built beneath military vessel, commercial vessel, and so on. Anything that can float on water, this place is capable to come up with the design and analysis of that object. Do you understand? Any question? Any question? Okay. If you don't have a question, I have a question for you guys. Okay. So.
All right, gentlemen. Good morning or good afternoon.
Good morning, sir.
Good morning. How are you today? What school is this?
Masterguide.
Masterguide. So I believe what classes do I have here?
Classes.
From GSS1 to SS3. Fantastic. Have any of you been here before? Do you know where you are?
Yes.
Where is this place?
Yes.
Naval Dockyard. What do we do at Naval Dockyard? Where ships are built, right?
Yes.
So a person that builds ships is called a who? A person that designs a ship is called? Anybody? Anybody? A ship designer is called what?
You know, you just raise up your hand and answer. You just know it's correct.
Last try. Any other person? A ship designer is called a naval architect. Have you heard of what's called naval architect? So a naval architect is an engineer that designs a ship. So naval architecture is a branch of what? Engineering. Is that clear? Naval architects are not the same as architects. Neither are they marine engineers. So naval architecture is a branch of what? Engineering. Any questions so far? Have any of you been on board a ship before?
No.
You haven't? Yes. Are they going on board after? Right?
No, sir.
They're not going on board?
Yes,
Right now. Okay, I would really love for you guys to be on board the ship. So, since you guys have not been on board the ship, kindly, can you all see this picture?
Yes, sir.
So this is a design of a ship. I'm sure after now we'll take you around the ship to see how a ship looks like. So a ship is being designed in what a ship design center. So where you are currently is what we call a ship design center. A ship design center is made up of architects, engineers, and project managers. So engineering of different fields come up together to what? To design and build a ship. So to build a ship, what's the first thing you do? You design the ship, right?
Yes.
Once you design it in the ship design center, what do you do next? You take it to the construction site where it's what is being constructed. So at Naval Dockyard Limited, we design and build ships. So this office is where we design the ship. After designing the vessel, we take it out to the construction site where the ship is what? Being built. How many engineers do you have here, or want to be engineers do you have here? You want to be an engineer? Good. How many science students do we have here? Fantastic. Okay, I'll throw out a question now. If you know the answer, just raise up your hand. Can someone tell me the Archimedes principle?
Don't talk to anybody. If you know it, just raise up your hand.
Who knows Archimedes principle? Just raise up your hand. Anybody? Anybody? I need one person to tell me. Alright, silence please, silence. One to try. Go for please. Fantastic. So let me simplify it better. Why I asked you about Archimedes principle. Let me ask one other question to that. Why do a ship float? Because of what? Buoyancy. Right? Now, can you see this picture? So this picture, a ship is what? Staying on water. Why isn't it sinking? Because of what? Buoyancy. Because of what? The upthrust force. So buoyancy is what? Your upthrust force, keeping the vessel to float. But you know that a vessel has weight, right? Acting what? Downwards. So the water is what we call the upthrust force, right? It tries to take the vessel up. Then the load of the vessel is what? Downwards. So the Archimedes principle, which I want you to study more, what does it do? It talks about flotation, buoyancy, trying to make your vessel float. So that's the basic principle when designing a ship. The Archimedes principle is the first law you have to know when designing a ship. Is that clear? Hope it's not too complicated. Are you sure? Okay, I'll let you people ask a question. Any question? Any question at all? Are you guys shy? You have an opportunity to ask a question. Any question?
What work can
One out.
I said, what work can a commercial student do?
What can a commercial student do in Naval Dockyard? Fantastic. Now, in shipbuilding, so let me ask you first, commercial students, what do they do? As a commercial student, what do you do as a commercial student?
Create budgets, prepare financial statements.
Fantastic. Now, in shipbuilding, do you know that 70% of your materials are sourced, meaning procurement? 70% of your project cost goes into the commercial sector. So your commercial sector is one of the most important sectors in shipbuilding. Good question. I like waiting. Clap for our please. Any other questions? Feel free. Any question at all? I need 3 questions. Anybody?
And what does a lawyer do?
What does a lawyer do? Good. So in any project we're involved in, especially in shipbuilding, there's always a legal part, setting up the contracts. For instance, now, if I'm an owner, I want to buy a ship or build a ship and you're the naval architect, I will come to you and ask you that, okay, this is what I'm looking at building. And so time. Then a lawyer has to draft a contract agreement between the builder and the owner. Does that make sense? So a lawyer makes sure that whatever is being agreed between the owner of the vessel and the builder is being followed through. Does that make sense? So there's also what you call maritime law. I'm sure you want to go into law. There's also the marine aspects of law, and then the shipping aspect. So you can look into that.
Civil transport all types of goods.
The ship transport all type of goods. Yes, fantastic. So there are different kind of vessels. We have the what we call the tankers, the oil tankers, which can carry crude oil. We have the container ship, which can carry containers. We have what we call the roll-on, roll-off, which can be used to carry cars. We have defense boats, which we can use to patrol our coastal waterway to protect our economy. We also have ferries that can be used to carry passengers. So you have different types of vessels.
Sir, for someone who wants to be a mechanical engineer, sir, can there be any correlation between naval architecture and mechanical engineering?
Very much true. Very true. These my two chaps are mechanical engineers. Like I said earlier, shipbuilding comprises of a team. When building a ship, it comprises of a team of not just a naval architect, but marine engineers, mechanical engineers, system engineers, quality engineers. They all come together in building a ship. Does that make sense? I've been waiting for someone to ask that since. She asked, can you sit down?
Please clap for her, babe.
So what materials are used in building a ship? I will throw it out. Can anybody tell me what are the different materials you can use in building a ship?
Raise your hand and speak.
Steel.
Good. Now, I'll list out different types of material. In building ship, we can use wood, we can use steel, we can use aluminium, and we can use composite material, aka fiberglass. Now, starting from history, among these four materials I mentioned, which was the first? Wood. Second?
Steel.
Third?
Aluminium.
Fourth?
Fiberglass.
So you guys know about this, eh? Fantastic. So why were we using wood in the days? In the early days, wood was the first material we used in shipbuilding. Then we evolved to the use of steel, which you see today. Then as technology improved, we got into aluminium and composites. So can anyone tell me what is the advantage of these materials over the others? What comes to your mind? Why should I use steel instead of wood? Why should I use aluminium or why should I use GRP? Any idea?
Durability and weight.
Sorry?
Durability and weight.
Which one?
Of materials when it comes to durability of wood compared to steel. Steel is more durable than wood as wood rusts. And using aluminium over steel is in terms of the lightness of the material.
In terms of what?
The lightness of the
The
material.
lightness of the material. Fantastic. So gentlemen, in principle, material selection is a very important part in shipbuilding. Now, let me give you two materials between steel and between aluminium, like what your colleague just said now. Why do we use steel? Why don't we use aluminium? Why do we use aluminium? Why don't we use steel? Steel is what is very ductile, is very malleable, meaning that it can be easily bent, right? It can be easily changed from one form to another. Does that make sense?
Yes.
Aluminium, on the other hand, is lighter than steel. So for a vessel to be lighter, it means that you require less energy to move it from point A to point B. And for it to require less energy to move from point A to point B, you require what? Less fuel. So if you require less fuel to move a vessel from point A to point B, you require less money, less cost. Does that make sense? However, Aluminium is much more expensive to purchase than steel material. Does that make sense? But what I'll tell you, in summary, in shipbuilding, naval architecture, and any of you that are interested in it, let me know later. Naval architecture is a branch of engineering that focuses on building of anything, any object offshore that can float, not necessarily ships. So naval architecture, we build any platform from oil rigs to barges to outboats to windmills, any offshore platform that can float is naval architecture. Naval architecture also offers consultancy, offers structural analysis, aerostatic analysis, designs, and whatnot. So it's a broad field in which you're looking at specializing. Not just this is just one part of naval architecture. All right, are we good to go? Is there a question? Why can't we build in submarine? We can build in submarine. It's all part of naval architecture.
There's someone stretching.
So I think Nigeria.
Sorry, please.
Don't talk until I recognize. Just raise up your hand.
Are they naval architecture universities or naval navy universities? Okay, do we have schools that teach naval architecture? I would say yes and no, in the sense that most of the schools in Nigeria, they teach probably a diploma or at a master's level, right? Then do we have naval engineering schools in Nigeria? Yes, for naval officers. Okay. All right. Okay. Small. This is the last small question. You.
After secondary school, is there any way we can go to naval school without going to university?
To go to a naval architecture school or you go
For
to
us students.
for us students to join the Navy? Sorry, please, everyone else. Sorry, I'm trying to get a question there. So after secondary school, you want to get an industrial training in naval establishments and naval school. So I get that clear?
Yes.
So yes, like I mentioned earlier, so Naval Dockyard, we have IT students that come in for their internship, so that can be done. All right. Okay, you and her, last time, sorry, you.
We were informed that there will be 3 ships designed here.
Yes.
Do you know how much it costs?
One house. Say one thing.
Good question. Yes. So the first ship of Nigerian Navy was designed and commissioned in 2012. The second one was designed and commissioned in 2016. The third one was commissioned December 9th, 2021. Now, in this 3 ships, yes, there's always a budget. Like as I explained to the commercial students over there, every project has a budget. You do a budget plan. However, the information is confidential for this house. But however, if you want to know the cost estimate on different sizes of boats, you can go online. There's always estimated cost from different boats. Just ask for the meter, 10-meter boat, 40-meter boat, 20-meter boat, however the type, you always get the information online. Okay, last question. Good question. So like I said earlier, right in this office where you are today is the art of shipbuilding. So this ship, everything we built, like the 3 ships I mentioned, was designed by Nigerians in Nigeria in this office. And also built by Nigeria in Nigeria at Naval Dockyard.
And we appreciate that.
All right, I think that should be all for now.
I have a question. Please. For those interested in the maritime industry, can you tell us how lucrative the maritime industry is?
All right, thank you. So let me be biased a bit and stream it down to naval architecture. So So the marine industry is a capital-intensive industry. The marine industry is a growing industry. About 75% of trade, if not more, is being carried out by what? By sea. Now, the marine industry comprises not just the oil industry, but other commercial aspects. So in the maritime industry, there's a lot of departments, a lot of sub-departments that want to specialize in, be it in the commercial aspect, be it in the law aspect, be it in the engineering aspect, you name it. The marine industry is one that we have not even finished exploring. It's one that is really growing. Now, boiling down to the naval architecture department. In Nigeria today, there are few naval architects in the country. There are few shipbuilding establishments in the country. However, the company is on this shipbuilding industry is on the rise, in the sense that ships are needed every day and every night to carry out various tasks. Like I explained earlier, there are different kinds of vessels. Those for containers, those for ferrying, those for different unique needs. So who is the art of the shipbuilding? Who performs this building? They are the naval architects. So if you can learn to design and build a ship, and the nation Nigeria have more naval architects in Nigeria building ships, guess what happened? Our country becomes more economically viable in the shipbuilding industry, getting more GDP, increasing more productivity, and guess what happened? Our country makes more money, and the economy of our country also improves. So it's a win-win for everybody and all the stakeholders. No, that's okay?
Thank you very much.
You're welcome to Naval Dockyard. This is steel workshop. In this steel workshop, what we do here, we do heavy duty welding. First of all, let me by defining welding. What is welding? First of all, let me define what is welding. Welding is melting two iron together to form one. It's what we call welding. Here now we do heavy duty welding. There are different kinds of welding. We have steel welding, we have galvanized welding, we have argon welding. Steel welding is your normal steel welding. Argon welding. This argon welding is comprised of electric welding, which you weld. You might not really know it's welding, and very simple. Then we have aluminium welding. Aluminium welding, not too hard, just very simple. You have the machine, you have welding machine, you have the machine here that you can use for welding machine instead of stressing yourself, using arc, stressing your eyes. So we have aluminium welding machine that we use for that. Then we have stainless welding. Then this stainless welding now is used in mostly industrial. You can't see it both sides. Used in industrial welding like this, for a bigger workshop like this. As you can see, we have too many ship here. This heavy duty welding now is for like the ship design, heavy duty welding. So that's what we basically do here. Any question? Okay.
How do they move the ship outside?
How do they move the ship outside? Okay, we have hangar. We don't call hangar. We have crane. You can see the crane.
Yellow color.
Yes, one with yellow color.
Do you know what crane is called? Do you know what crane is?
So the crane now, they will hang it. When they hang
Don't worry,
it,
when we get to the yard, I'll show you crane.
please
Just remind me when we
the
get
crane that will
outside.
carry the ship after we build it. This is the ship that will carry the crane inside the dock. When you get to the dock, you see the dock. Any question again? Ask question. This is when we workshop. Ask questions. Because some of you might want to be an engineer, when you grow up. So you ask questions so that when you get there, you know. Just anything like that. Sir? What is? Okay, mechanical. You said what? You say what field of engineering is this? It's mechanical.
It is mechanical.
Mechanical.
Okay, let me give you in a nutshell what is trying to say. This is steel workshop. When you're talking about steel, it has to do with welding or joining two or more metals together, Abi, to form one.
Yeah.
So now what it's trying to say in essence, now you can see these boats that are here. These boats are not just formed like that, Abi. They are joined together, that is based on welding. Before any ship construction is being carried out, after the design center have brought their design plans and everything, then they start the welding work from this side by joining one or two metals to make the hull and the skeleton of the ship before it is taken outside for remaining processing. You people understand? So it's just like you now, maybe you want to form a metal box or a cage. You carry one iron, Abi, join with another iron till you form what you want to form, Abi. So that is going to form the body of the shape, the ship and things like that. That is what it's trying to say in essence. So every welding processing is being done in this workshop.
We have a sample here.
Every welding, any kind of metal can be welded in this
This
shop.
is a metal. This is a metal. I have to weld it together. One.
Welcome to Naval Dockyard Limited. I suppose people have been to the design center. Cannot hear us? Don't worry. I will shout. You have been to the design center, but so they told you how the ship is being designed. But you know you cannot carry that paper there and put it on top of water. So from the design, this is part of where you start your key laying and some other engineering activities. So while you're coming inside, I suppose you read outside every engineering workshop, or most of you did not see it. So this is heavy mechanical workshop. What we carry out here, we carry out heavy duty maintenance and repairs. So all these machines you are seeing here, they are heavy duty for heavy duty purpose, both for cutting, milling, and any type of metal reducing operation. Metal reducing operation means that you have a particular metal and you want to shape it to a particular size and form that you want. You know, if you have okay, for metal work, it is better that the metal is big so that you can reduce it than for the metal to be small. So we carry out metal reducing operation in this workshop. So almost all the machines you see here, from the lathe machine, all these ones, they are all lathe machines. This is the lathe machine, this is the lathe machine. So the drilling machine, like for this lathe machine now, you can see these are particles of metal. Like I said, it's metal reducing machine. So what the machine does is they cut your metal to your own specification. Any part of the metal you want to be reduced, that's what the machine will reduce. So these are particles of the metal. They are very sharp. And when the machine is functioning, they are also very hot. So you don't touch them unless you have your PPE, like the safety officers must have. So from where you are coming from, I don't know, do you have any questions from where you are coming from before we proceed to the main graving dock? That's the main essence of Naval Dockyard. Do you have any questions from where you are coming from design to the field of Dockyard? Okay, turn your back. To go front or back with the end of this particular item. This is the propeller blade. So the essence of your engine on board is to allow this blade to turn. If this blade is turning, that means your ship will be going front or back. And this is the propeller blade that holds this is the propeller shaft that holds the blade. So like I said, metal reducing. Let's say there's a bend, there's a vibration on board, and this particular shaft now is bent. Maybe because this shaft is too expensive, you cannot buy a new one. You can come and say, we call engineers and say, okay, we want to straighten this shaft. That particular point that you bend, you might fill it with metal. And when you are filling it, the gap between that place we fill and this particular metal will be higher. So we need machines like that lathe machine to reduce that part of the metal that is higher than the original portion that we want. So that process is what we call metal reducing, and that operation can be carried out only on the lathe machine. That's why I see that lathe machine that is very long. To accommodate all the shafts, you can see that the shafts are different sizes. So if you have a very long propeller shaft, we use the longer lathe machine. Then if you have a smaller one like this, you can use all these other smaller lathe machines. But let's go to the main door. The brain of that aircraft will be the engine. What makes that aircraft to fly, or what makes that vessel to propel either front or backward. So this is a typical example of one of our engines. Like the engine you are seeing now, this is a 4-stroke engine. We have 4-stroke and 2-stroke. Some of us want to be mechanical engineer, but okay, some of us want to be mechanical engineer. So in mechanical engineering, these are our major operations: how to design, repair, and maintain engines of any type. This engine that you are seeing, it has just one purpose, and that purpose is to allow a particular point of the engine to rotate. That's all. You just need that rotation. There is no difference between this engine and a typical electric motor. So what we need there is the engine to make a particular part of the engine, the engine to rotate. That rotation is just what we know. We have electric cars now. Yeah, we all know we have electric cars. Yeah. So if you find out the difference between an electric car and a typical normal vehicle you see on the road is the sound, the noise. So this engine will generate more noise than your electric motor. So this is a typical example of one of our engines. This is a V engine and 4-stroke, and it has 1, 2, 3, that is double 12 cylinders. But as you advance in your career, you get to understand what those stands mean. But just for instruction, this one that I see now, this is a typical example of this is one important part of the engine. So this is the sleeve. Okay, let me. Getting yourself stained with grease and oil is part of engineering. So this is one of the most important parts of the engine. Without this component inside the engine, your engine can never work. So what this thing is called now, this is the piston. We call it piston. Why this part is called the connecting rod. They all have their various functions, but I don't want to bore you with the lengthy explanation. But because you are seeing it naked outside, that's why I just want to show you. So this is the connecting rod, this is the piston. When you hear about combustion, the combustion takes place on top of this particular man. So this man is very, very strong. They are all covered because of dust, so that the dust from the environment will not get to it, because if the dust gets to it, it can make it to get caught in short time, because we still want to use it. So that's why you see that all of them are covered to prevent dust and other dangerous particles to fall on it. So that's all for this way. So you can see inside of it, you can see those blocks there. You can see those blocks that are arranged there. Those blocks are arranged to accommodate one of these vessels, one of these Navy ships. So those are called These arrangements are done by those called the design office, because they have the skeleton of the vessel, like the raw data. They know how to arrange that. When the vessel comes inside, you can sit on top. So that one is called keel block. That's where the ship sits on top. The bottom of the ship is called a keel, K-E-E-L. the bottom of the ship now is called keel. That's why we refer to it as keel block, where the bottom of the ship sits on. So it's called keel block. Now, how does this dock function? You can see like there's a gate there. That's the main gate of the gate. That's the gate. It's very big, but you can see maybe it's small with your eye now because they have not opened it. And behind that gate, we have that open water there. So this gate now is restricting the water from getting inside. So now, what if a ship now wants to enter inside? What will happen? You cannot just open that gate and say, maybe Musa is opening the gate there. So, you open that gate as if you are just opening your door to enter. The pressure of the water can even injure the person opening the gate or damage the gate itself. In engineering, we don't play with pressure. In engineering, we don't play with pressure. Pressure of any kind, whether air pressure, water pressure, whatever type of pressure, because high pressure is very dangerous and you cannot even measure it. You cannot predetermine what that damage caused. So because of that, we take all precautionary methods. So the precaution we take here is we pump in water from the ship. Why the gate is closed? Let's say the vessel wants to come inside. We want to dock a ship. We pump in water from the sea inside this dock. So this place now, we now pump water as if you are filling your swimming pool. By the time the water gets to a particular level, where the back pressure and the inner back pressure is almost equal, so that when you open the gate, there will not be that, you will not experience that so much difference in pressure. So when you get that extent, you now lift that gate. The middle of that gate now is a tank. That people you are seeing there is a tank, and that tank right now is filled with water. So that water is acting as a weight towards that gate. So by the time I want to lift that gate now, I have to pump out that water. That water will now act as that tank now will now act as a balloon to enable that tank to float on water. If you open that gate now, this tank now will start floating on top of the water. You don't see. Because that middle there will be air, will be filled of air, not water again. So when the gate is open and to one corner, the vessel will be guided inside. While the vessel is coming inside, your engine will be off. You don't need your engine to drive in. You just pull you in. Then when the vessel is inside, divers will be here to monitor that the keel is interacting with the keel block in a particular position. But if you don't position it well and you pump out the water, anything can happen to that vessel. It might get damaged. And any part of the vessel can damage, especially the propeller. The propeller is one very important part of a ship. Without the propeller, your ship will not move. So that propeller and the propeller they are very important. So when the divers make sure that the keel of the ship, that is the bottom of the ship, is exactly, you can see that the thing is long. So at every mark, you have to make sure that this particular point is on its right position. So the divers will notify the people, then they pump out this water gradually. So as they pump out the water will be reducing, and the weight of the ship will be sitting on this thing like that. So when it sits properly, you pump out the rainy water and clean the dock before you carry out your maintenance. And before you bring in your ship, you already know what you want to repair in that ship. It's not that you bring it inside before you start knowing what to do, before you start asking questions on what to repair. So while the ship is still outside, they will tell us what they want to repair or what they want to change, the maintenance they want to do before they come, so that when they come inside, those things will be done almost immediately, because every day it sits here, the money will be spent. Then when the ship wants to go outside, let's say after repair, everything has been confirmed okay, when the ship wants to go outside, almost the same procedure has been carried out. You pump in water again. When the ship pressure are almost the same, open the gate, you carry your ship outside, you close your gate, and you pump out the water. But there's one advantage after that one. You normally see fish inside the dock. So that one is That one is for bonus for people that are waiting. Okay, let's go to the twin dock. The water. We use pumps. There are pumps. There are different sizes of pumps that are inside these docks. You may not see it, but they are present in different parts of the docks. So when you need the water out, you just press a button and the pump will pump the water. The pump is electrically controlled. There is an electrical pump. You use electrical pump to pump the water outside or inside. Our question is, why is this ship up there instead of here? You can see that this place is very big. This place now is bigger than like 3 or 4 of these vessels. So it's almost a waste of time or waste of resources. Why to build this particular thing inside here? So it will be occupying space for other bigger vessels to come and carry out maintenance. And this is now because these are designed in that particular position. You can see that one and this one there built here. So they are still under construction. This is a tactical badge, a self-propelled badge. So it's not really a crash, it's a badge. The function is to convey, what they are designing for is to convey fuel or water from, let's say, there's a bigger vessel at sea, and the vessel needs fuel or water. These are the kind of watercraft we use to convey water or fuel to them at sea. Test. Yeah, after repair, you can carry out your test here. But you know, let me tell us something. The difference between the vessel and your normal car you see outside, the major difference is the cooling system. So why this badge now, self-propelled badge, we cannot start the engine because it's not on the water. It needs water to cool the engine, and the marine engine can run continuously for 1 month without stopping, unlike your other generators and others. You can just run it maybe 24 hours or 48 hours at most. But for marine engines, because of the cooling system, it's designed that the seawater will be cooling the fresh water that is cooling the engine. So you can see that almost 3 particular liquids are cooling the engine. So the engine is. What's your question?
How do they bring out the ship?
You say?
How do they bring out the ship?
Bring
Out the ship.
I told us how to do it. If a ship wants to enter here now, if you follow the water, it's not crane. It's not crane that will put it inside. If you follow the water inside, if you see that side now, that's an open water. That side is open water. So when you open the gate, after following the processes I told us, when you open the gate, the vessel will come inside and sit on top. After repair, you open the gate, the vessel will go outside. But for smaller boats like this, we can have crane to lift them and drop them where they are now. Then for your question, how long does it take to... Can you hear me? So what's the difference between this one and that one we saw that time?
It's smaller.
This is smaller. That's the only difference. Every other thing is the same. But the name we gave to these two, they are called twin dog. You can see that they look alike. So this one is a twin to the other one, but I don't know which one is Taiya and which one is Taiwo. So anyone can be Taiya and Taiwo or Kainde and whatever. So look behind you. See that small boat? You see that small boat? Look at the back of it. You see the tiny propeller and the propeller shaft. You can see how tiny it is. That means very small compared to what I showed you at the workshop. That boat you are seeing there is a pleasure boat for enjoyment, for people that want to go and enjoy in the water. So that boat now, it has everything. It has kitchen, bedroom, it has rooms, toilets and bedroom, everything inside as it is now. As small as yes. So everything is inside. So it's called pleasure boat, just for enjoyment. And it's not built with metal. It's very fragile. So you turn back.
Listen.
Yes, it's working, but it's under maintenance. Can you all hear me?
Yes,
You see this baby here, this one? This one that is painted with ash. This one is called a floating dock. What do I call it? That means that whatever that can be done inside this dock now can be done inside that particular floating dock. Inside that particular floating dock. And the function of that floating dock is, let's say I have a boat now that is stranded at sea. The engine is not working, and the people that have the boat doesn't want the boat to come to this part of Nigeria. So what will happen is we take advantage of this floating dock, we tow this thing to where the ship is and sink it. The way we have docking and undocking there, that's how we have docking and undocking here. So let me go through the docking. When you want to dock a ship here now, you have to sink this particular structure now. You sink it inside water. So how do you achieve that? There are tanks, there are empty tanks inside this particular material you are seeing now. This floating dock you are seeing now. There are certain tanks that are empty. So when you start pumping water inside, that time is called flooding. When you start flooding it with water, the weight of the water will now be taking this floating dock down. So the deeper it goes, the more any type of vessel you want to accommodate inside can enter inside. So just as the keel is arranged there now, you can see that pipe now. Check under that pipe. You see something under the pipe that the pipe is sitting on top. So that's the function of the keel block. So you arrange those type of things so that when the boat enters, it can sit. Then when you want to undock, so undocking here is just for you pumping out that water that you pumped inside those empty tanks. You pump them out so that this floating dock will come up again, and when it comes up, you see your ship sitting on top of it, just as this pipe now is sitting on top of it like this. So that's the pattern. So this is regarded as floating dock, and you don't use it at shore like this, but you can use it on shore like this, as you see it like this now. But its major function is when you take it to the high sea to use it, or any other place, but you don't use it on land. So there now is for land, a land dock. White zona is a floating dock. You can tow it to Warri, to Port Harcourt, to anywhere part of Nigeria, but you cannot move dockyard. Dockyard is unmovable, but you can move this particular one. This one is its own dockyard. It has all the facility inside. So that's it about the twin dock and the floating dock. So we can go back.
Just go like that, where you are.
Now welcome to the electrical workshop, which we are proud to say is the art of the Naval Dockyard. You know, most things nowadays is being moved by electrical gadgets. So what we do here mostly is we do rewinding of electric motors, alternators, transformers, and as well we build control systems for all those gadgets on board our naval ships. So we just kind of do some introduction, then I will show you some of the machines we use in carrying out the operation. You know, electrical rewinding is like if the electrical part of a machine is defective, that is when we come in. Either the controls or if the coils are burnt. You can see sample of electric motors around and alternators. So those are the work we do. When they are burnt, we bring them down to the workshop. After we have conducted our own code test and we have confirmed it, we strip it and we rewind it. You know, what we do here is to just replace what was defective. Remove the old windings that is burnt and replace it with a new winding. The same size, the same connection. Also, you can see panels around. When the controls of these machines are defective, we go in there and we do the troubleshooting. After the troubleshooting, we normally rectify the fault so that the machine can continue to work. So, the machine you're seeing here now is one we use out in carrying out all the windings for alternators, electric motors, and transformers. But the job we do here is purely low tension. What I mean by low tension is from 460 volts to 110 volts. You know, we have high tension. High tension starts from like 3,000 volts to 132,000 volts, which is common with NEPA equipment. But here we deal with low voltage. It could be 50 hertz, that is the NEPA frequency, or 60 hertz, which is the one that we use on board. So this machine is called Universal Coil Relay Machine. It's the one we use to prepare the former to do the rewinding. After we do the rewinding and we have done the connections, we do code test with some meters. We do the high voltage test. How many of you are science students here? How many of you are offering physics? Okay, so I think I have colleagues here. So you other guys should aspire to become engineers. You understand? Am I making sense? Aspire to become an engineer. You can see that we are backward in everything. Isn't it? So after we have done the rewinding, we take it to that machine where we do the vanishing. The vanishing is like, it has a reason. Look at the sample here. After we have done the winding, there's a chemical we pour on it. We call it varnish. After we pour that chemical, we put it there for some moment so that the chemical can penetrate inside. After which we take it to the oven. The oven is not the type we use in the house. This one is the conventional type. It's an industrial oven. It uses air system to dry up this according to the temperature of the dielectric. The people that are offering physics, when I say dielectric, what am I talking about? Insulation. Isn't it? The insulation. There are some dielectric they break down at 80 degrees. There are some they break down at 100 degrees. There are some they break down at 120, some 155, some 180. So it depends on the one you use. And that is what you use to set the thermostat of the oven. So after you have dried it, you will now couple it, and then behind you is a test bench. We will test and we'll make sure that all the parameters of the machine equals what is written. There is always a nameplate on it by the manufacturer. The current, the voltage, the frequency, the speed. So when we take it to the test bench, we observe all those parameters for about an hour. And if the temperature and everything is okay, we now return them back to the ship. So we do transformers also, like the NEPA transformer, low tension, not high tension. So if you have any question you want to ask, you can see the crane. You know, these things are very, very heavy. Science students, anything that is above half of your weight, you should not carry, isn't it? So this is a crane that helps us to move objects from one position to the other. And safety is very, very key to our work here. So if you have any question you want to ask, anything related to you are free to do so.
How is this office for?
This vent?
Yes.
Okay. You know, the reason we call on this thing is called varnish. And those days it used to be toxic. It used to be toxic. So anytime we are applying it, we put, this is just an exhaust to suck the smell and take it out so that it will not harm those of us that are in the workshop. You understand? When we are applying that, but the whole of this place, you know thinner. You know what is called thinner? It's very choking. So that the chemical will not choke us. This is an exhaust. Just suck that smell and take it out so that it will not harm us. Which other one would you like to ask? Any other question?